Okay, so in this problem, one key thing to clue on here is they're telling us that there's a sequence of 3 digits. Now, if you think about a number with digits, does order matter? So if I tell you, the number 345, is that the same number as 543? Well, clearly not. 345 is very different than 543. So here, this is going to be a permutation type idea. That was the worst writing of permutation ever. Let's try that again. Okay, so it's a permutation. So this denominator here, close, but not quite right. We need permutations down here because its order is important. Now the next thing that comes in the permutation is to say, can we use our permutation notation, or should we just write the blanks? Say we've got 3 blanks. Now how many choices do I have for the first one? 10. Now because there's, I think I'm already seeing, you see that there's 10 digits, 10 different numbers to pick from when we go 0 through 9. So we could pick 0 through 9. Now, if we're allowed to repeat, we can pick through 0 through 9 again and 0 through 9 again. So it's 10 times 10 times 10. So that denominator is just going to be 1,000 different possibilities. So there's our denominator. Now for the numerator is going to get a little more fun. You're on the right track. You're on the right track with this, because what they're saying here is find the probability that 2 of the 3 digits are the same. So first thing we need to do is say, okay, pick a digit. Yeah, dead on. Out of our 10 numbers, pick one for the ones to be the same. We'll call this the same digit. So we have 3 digits. Now we know 2 of them are going to be the same number, so we're going to pick one of our numbers. So let's say it's a 2 and a 2, or it could have been a 2 and a 2, or it could have been a 2 and a 2. All right. So now we have to take care of all this. Which of the 3 digits are going to be the same? So out of our 3 digits, we need to choose 2 of them to be the same. So this right here takes care of picking which number the same ones are going to be, and in which spots they're going to go. Okay, so now that we've done that, you've correctly clued in on now we need to choose another digit. It can't be the same, because then we'd have all 3 digits the same. So out of our 9 digits, we need to choose the 9 digits that the 9 numbers we have to choose from. We have to pick one of them, and then we're going to fill that one in the remaining space. So out of the 1 remaining, we could choose 1. So that'd be 1 combinations of 1, but that's kind of silly to write. So most people don't write it. They would just leave the problem just like that. So I hope that makes sense. You were really, really close. You just right here, your issue was just choosing one digit perfect, choosing it twice. You don't choose out of what you're saying here. When you do 10 combinations of 2, you're saying out of our 10 numbers, how many ways are there for me to have to choose 2 of the different numbers? I could pick a 1 and a 2, a 1 and a 3, a 1 and a 4, that kind of thing. Not which spot do they go in, if that makes sense. So great logic, just it's important just to see the difference, and that's why we do millions and millions of these problems for practice, because it just takes practice and time. Hope it helped.